Hello there! In this tutorial, we'll continue learning how to load data with NumPy. More precisely, we'll be going over simple data cleaning techniques we can take advantage of while importing a given dataset. This is beneficial when we're familiar with our data and only prefer to load a portion of it to save time and memory. We'll begin by using the GenerateFromText function to import the lending company numeric data nan.csv file. This CSV uses semicolons as delimiters, so make sure you set that as well. Of course, we also want to see the fruit of our work, so we display the newly imported dataset as well. Right. This output will serve as our reference for this lecture, so we can just scroll up whenever we need to compare something with the initial input. Now, copy the code and paste it in a new cell. Before running it, consider that the gen_from_txt function has dozens of parameters we can use to modify the way in which we will import our data. You can examine them by either visiting the relevant page in the NumPy documentation online or accessing it via Jupyter with the Shift and Tab combination. Anyway, what we'll do is add skip header equals 2 within the parentheses. This should remove the first 2 lines of the dataset. This becomes convenient when text files include several lines of comments or notes from the authors before the actual data. By setting the skip header argument, we can omit as many lines as we want from the top of the dataset. Of course, it's best to test things out for ourselves, so let's run the cell. We see that the first 3 rows are different from the complete dataset. Since we've removed the top 2, we expect that what we used to be the 3rd row is now at the top. If we take a closer look, we'll see that's exactly the case here, so skip header works as intended. We just saw how to remove values from the top, but what about ones from the bottom? Well, once again, copy the code from this cell and paste it onto the next one. Then simply switch header to footer to obtain the skip footer parameter, and we're set. The new code will disregard the last 2 lines of the dataset when importing it. When we run the cell, we see that the last line starts with a not a number value. If we scroll back up to the original dataset, the 3rd row from the bottom starts with an NaN as well. Just as earlier, if we look closely, we'll see that the 2 rows are identical. So the skip footer behaves as expected too. So, we know how to disregard certain rows already, but what about columns? Well, we can do that too. Just like before, paste the code onto a new cell, but make sure to remove the skip footer part. Then, set the useCalls argument, whose name derives from useColumns equal to 0. Doing so will tell Python we're only interested in the first column. If we want to add more columns, like 1 and 5, just put all the values in parentheses and separate them using commas. That way, we're telling Python exactly which columns we want to use. Okay, let's run the cell. If we scroll back up to the original dataset, we'll see that the new output only contains the first, 2nd, and 6th columns of the complete file. Python, among other programming languages, uses 0 indexing, so this perfectly matches our expectations. Great! An additional layer of usefulness comes from the fact that we don't have to import these columns in order. To elaborate on what we mean, change the order of the values in parentheses from 0, 1, 5 to 5, 0, 1. After running the cell, we see that the new output contains the exact same values as the last one, but in a different order. Since we put 5 first, the 6th column appears furthest to the left, while the other 2 have shifted to the right. As a matter of fact, this technique can be extremely convenient when we want to sort the data according to a given metric, which isn't stored in the farthest column to the left. Right, having all these options at our disposal is neat, but what's even better is we can combine them. Once again, copy the code from this cell and paste it into the next. Then simply add skip header equals 2 and skip footer equals 2 and run the cell. This time, we don't even have to scroll all the way up for the comparison. because we only need to look at the output from the previous cell. We see that the first two and the last two lines are no longer present for any of the three columns. Hence, these arguments work well in unison. Okay, we saw how to select what part of the dataset we want to import, but what if we wish to split each one into an individual variable? For example, first column is one variable, second column is a different one, and so on. Well, Python's tuple assignment dictates that we write the names of the variables one after another, separated by commas. Let's see if that works here. Interestingly, we get an error stating too many values to unpack. This means that the function is trying to pass a single value to three variables, so this doesn't work. Thankfully, the solution is straightforward. Just add unpack equals true within the parentheses. This will tell the function to split or unpack the output in three different streams, one for each variable. To showcase the outputs of multiple variables in the same cell, we need to call the print function. So make sure to do so prior to running the cell. Fantastic! We see that each variable contains the data for one of the three columns we're importing. Notice that the first variable contains the sixth column of the original dataset because of the order we assigned to the useColumns argument earlier. It is important to remember this because otherwise it can lead to unnecessary mistakes. To conclude, you saw that we use several parameters of the NumPy's generate-from-text method to import our data in a specific way. Please don't forget that you can always consult the documentation should you need to get ideas on how to further improve the file you import. Awesome! Now that we're done importing text files, we can turn our attention to something different: JSON files. In the next lecture, we'll discuss what they are and how to import them into Python. Thanks for watching.